Today we're going to show you Dezignworks 10 inside of Solidworks 10. And as you can see, the Dezignworks toolbar matches your Solidworks tool, so it's very easy to learn and use as you begin working with Dezignworks. First, we need to orientate the part with the arm so that the arm knows where the part's at and also knows where it exists inside of Solidworks. The alignment allows you to go through and reference some planes, X, Y, and Z axes, and also create an origin location for that particular part. The nice thing about Dezignworks 10 is that in the advanced alignment you can now select a plane to reference as the bottom of the part. So here we're going to identify the top plane. You'll also notice that that alignment exists in the feature manager tree. Now we'll start a sketch and use the line command and just walk the arm around the part and quickly build lines right inside of Solidworks. These Solidworks lines are native line geometry and they're not imported in any way. We can also do arcs. As you'll see, we'll capture the top of the part using a best fit arc, and then we're able to go right in and use standard Solidworks tools to trim up that geometry. So here we're just trimming and extending these lines and arcs to make a closed profile. Again, all of this is native inside of Solidworks. There isn't any translation of any kind. Now we're going to extrude it and select the top of the face to actually extrude up to, and that gives you our thickness. So very quickly we have solids right inside of the Solidworks environment to continue working on. Now we're going to do the complex surface along the top edge of this part. And that complex surface requires a few different sets of geometry to allow us to capture the information. So first, we're going to outline where that surface exists, again using standard lines and walking around that area with the probe. And then we'll use those lines to create some surfaces that we're going to scan through. And within Dezignworks, you're able to actually take surfaces or planes and scan through them to get cross sections. We're actually going to get some cross sections of the top complex surface there. So now that we have the surface created that we're going to scan through, we're going to go into a lock surface tool, which allows us to select a number of surfaces, and you'll see them pop up in the feature manager tree on the left hand side. We're also going to start to scan across that surface with the probe, and you see the points actually pop up on the screen every time the probe passes through that surface. The key thing here is that we're able to take the probe and just scrape it across the surface in any direction, in any orientation, and as we move across that surface we're getting a point at every instance. We can also identify how close those points are placed to each other and what the tolerance is across that surface. The nice thing that you'll also see is as we do this, we have the ability to both get splines or just reference points. And here we're actually doing splines, and we're creating individual splines. We could also have closed splines as well. The graphical information that you're seeing on the screen also lets us know where we need to take additional points, and we can move back and forth in our scan to get all the necessary information we need. The other thing about this process that's unique to Dezignworks is we don't have to go in a systematic fashion. We can overlap, and we can continue to move the probe wherever is necessary. We can also rotate in our environment to take a look, at some more information along the areas that we're trying to capture geometry. So we'll go ahead and allow this to create the splines. And you see the splines quickly created. That scan is also saved in a file that we could reuse if we needed to. Here we're going to create some quick surfaces out of this geometry using standard Solidworks tools. Once we've done that, now we're just using standard surfacing tools to provide us some additional geometry that we're just going to extrude up to using a standard extrude command. Within Dezignworks, you can use the standard Solidworks extrude features and cuts, or you can use the Dezignworks extrudes. So here you see we quickly, within about a minute and a half, was able to recreate that complex surface on this part. Now we'll continue to create a geometry with some cuts and holes. And here we're going to capture the 4 holes in the top portion of that surface. One of the nice things about Dezignworks is you can get comp automatically, and we can do inside and outside comp for lines, circles, arcs, and splines. We can also do for construction or make the geometry solid geometry. Also, we're able to capture things like design intent with the geometry as it's created, horizontal, vertical, as well. Here we're going to make these 4 circles, and we'll be able to digitize them, and then also go ahead and add some standard SolidWorks relationships to them. Like if we knew that they were all supposed to be equal, we could do that as well. Now we're going to go ahead and just use the standard SolidWorks cut tool and do a through all end condition, capturing some design intent inside of our design, even though it's being scanned. Now again, we'll also do the same way for the center circle. We can do 3 points to do circles. We can also do a best fit circle. Here we're doing 3 points again. You see the compensation for the size of the ball probe, and we'll now use a Dezignworks cut and go down to that inside surface which we just picked with the probe. We'll do another quick cut to finish that off, and this one will be a best fit instead of 3 point. And so here we'll drag the probe and get a best fit based on a number of points that were selected using our standard cut feature and go all the way through. The next thing we're going to do is actually do use a hole wizard to do a counterbore hole. And in this case, we're just going to use the circle for location. So we're going to actually turn on construction. This gives us the flexibility to capture the information from the part, but then use some standard SolidWorks features like the hole wizard to get us the proper hole with all the necessary hole information that we may want for our 2D drawings. So in this case, we're actually going to create a counterbore hole, and it's a little bit hard to see in the camera, but we're going to do a counterbore hole using the hole wizard so we get all the information we need, type of hole, all the different dimensional information. Now we're just going to pick the point right on the model that was captured using Dezignworks. And so there again is our counterbore hole. Again, all these features are features in the Feature Manager tree. They're all SolidWorks native features, and we have the ability to go through and make changes to them at any time. The next set of geometry we're going to create is the steps along the right-hand side. This is also another example of doing some 2D sketching with some lines using the probe as the input. Here the nice thing is we're doing automatic compensation. We're doing a bunch of lines very quickly, or capturing a bunch of edges very quickly using the probe. And then we'll be able to step back again and use the SolidWorks tools to trim up that geometry to create some closed profiles. The thing that's nice about working in this environment is you're always inside of SolidWorks, because Dezignworks is a fully integrated gold solution product. And we never have to leave the environment. We're not doing anything outside of SolidWorks. Again, showing some of the level of integration, we're doing a cut, and we're able to use the contour select, which is right inside of the Dezignworks cut tool off the Dezignworks toolbar. Now, just like the lock surface where we're able to capture a cross-section of information, here we're going to do a lock plane. We're going to use it in a way that is a bit unique to this type of application. First, we're going to get a location for the cone that's sticking up off the top of the surface, again using construction, because we're just going to use the location of the center point of that circle. And we're going to offset a plane up to that center point, and that plane is going to become our lock plane that we're going to take a cross-section through. So here we're using a standard SolidWorks function of the offset plane tool and picking a point for that plane to offset to. And now we'll pick our lock plane, and we'll change our orientation so you actually can see the probe move through that plane, and every time it does, you'll see the point get picked up. We also don't have the sound on the arm on for this particular video, but every time the probe passes the plane, you'd actually get an audible indication as well, so that you know that you've gone through that plane as you're scanning. This time, instead of doing splines, we actually just did points. So these points can be used to draw through. So these points are actually locational information here. So we're going to go ahead and just draw some standard SolidWorks lines in conjunction with the points that we created with our point tool. what we'll be able to do then is use this to actually get a cross section through this circular shape. Inside of Dezignworks, sometimes you don't automatically comp, and so here what we're doing is we're actually doing our comp for ourselves by offsetting this geometry right inside of our sketch. So we've just offset half the diameter of our probe, and again just drawing with some of the standard Solidworks tools. What we'll be able to do with this once we get the profile created is to actually then take and use our revolve tool and finish up this geometry fairly quickly. The nice thing about this is we have a perfectly revolved shape that was based on the information we captured from our part. A new tool inside of Dezignworks 10 is the ability to get a center point of a sphere. So here we're going to do a 3D sketch with a point and use a new sphere command. We could also do circle center and edge intersection. So we're going to go around this half sphere and pick up points, set of 4 points, and that'll give us the center point of the sphere that we'll also use again in a plane offset to do another locked plane example. Now the locked plane is used quite often to do some complex surfaces and get multiple surface cross sections that we can use as loft sections to create some complex geometry. You can see that in some of the other example parts on the Dezignworks YouTube channel as well. Now this particular sphere we know is a half circle, so we're just going to take some points in our locked plane that are along the bottom edges and also across the top center, because we know that we're going to draw in a circle or an arc that's actually a center point arc to just give us our cross section that we're going to again use to revolve. Again, the benefits here is everything's native SolidWorks data, so we know that these points, we can reference them to create relationships to them when we build this arc geometry, and we can edit the sketch that was just created by that locked plane to put in SolidWorks geometry. Again, we may want to offset the arcs that are going to be created so that we get an accurate offset from our ball size. So here we're going to use a standard center point circle and create some relationships to those points, and then we'll go ahead and close off that profile once we offset the geometry the size of the probe. In Dezignworks, you're always working in conjunction with your Solidworks. So as well as you know your Solidworks, the knowledge you have of your Solidworks tools is going to make the use of Dezignworks very, very easy for you as you go through and create your geometry, because you're basing the way that you would model using standard SolidWorks tools and just taking again the input from the arm and using that input along with Dezignworks tools to get the geometry that you need. The last thing we're going to do is actually create this angled cut, and we're going to do that by creating a Dezignworks plane. So we can create a plane inside of SolidWorks using Dezignworks tools, which will actually allow us to take 3 points on the surface and get that angled surface inside of there. So we know it's flat for one, and we know it's orientated properly because we've created it with Dezignworks. It would be very difficult to get that angled surface that is just positioned somewhere in space without having the use of the Dezignworks tool as we're reverse engineering this particular part. Now we're going to use existing edge geometry and the creation of a line using Dezignworks, and we'll go ahead and draw in some extra geometry and trim it up so that we can remove this material away from the part. Here we'll finish up this part with a few more commands. What you've seen in this video is the ability to reverse engineer entirely inside of SolidWorks, leveraging all of its features and the features of Dezignworks. This allows you to reverse engineer in a much faster and easier way.